So we'll go through 8 and 15. Any other ones, you guys? 14.
You got any questions on the back
What the heck did I do wrong? I'm not gonna get 2 out of 4. I'm gonna get like 1.5 out of 4. I didn't do this wrong.
Any other questions, you guys?
What's taking so long? What did I ask?
Yes, you did.
For Dylan to do his turn.
Yes.
Like 3 people fired. Oh my god. No, I'm not.
Owen, it's your turn. I'll join you.
Shut up.
Big man.
Little baby.
Good.
I have 5%.
Thanks for the return.
Girl.
David, why do you want to know where I am so bad? Because he starts with the freaking sword people. I'm gonna hide on both. I'm not gonna be here. What? Oh yeah, this is
My board is being weird.
my desk is
Oh, you know why? It's because of this.
So basically, we can't.
What do you think is gonna happen?
It's because of that.
Every play has a
Hey, my desk can run by itself. Hi, Diego. Hi, Diego. Hi, Diego. Hi, Diego. Hi, Diego. Hi, Diego.
Hey, we have 6 days.
Bye, Luke. Bye, Luke.
Sorry, can you turn yourself back around? Sorry.
Whole turn.
I know. But you won't be able to.
What do you mean this is?
Hey, guys.
What?
I got $30 my car.
He knows everything.
Okay. So let's talk about number 8. We'll start there. Okay. So in number 8, I would like to do a bunch of cross canceling. We're multiplying these. We do not need common denominators. But the 35 and 7 can both be divided by 7. And they become a 1 and a 5. Then looking the other way, the 12 and 36. 12 goes into 36, so that can become a 1. And then this is a 3. And then I have x squared on top and just the x on the bottom. That means there's more x's on the top than the bottom. There's 1 more. So it's just a single x on top and then 5 times 3, which would be 15 on the bottom. All right, so going down to number 10 here. So we keep the first one, switch it to multiplication. So I multiply that and I make this 11 over 21. Again, we can do some simplifying first rather than trying to multiply like 99 times 21 I would need a calculator for. So I prefer to try if I can see if I can cancel anything first. So 99 and 11 can both be divided by 11, so that'd be 1 and 9. But then going over here, these can both be divided by 7. So then that's a 2 and 3. Now if you didn't notice one part of that, that'd be fine. You could just simplify at the end. But now we can just multiply across the top, which is 2, and across the bottom, which is 27. Can you figure out where you went wrong? Yeah.
19 is 21.
That is a fact. It's a hard one to disagree with. But yeah, silly mistakes. But. All right. So 14 and 15. So number 14 has addition and division all in one problem. So I'm going to add the tops and then add the bottoms, and then we'll worry about the division. So now the 1/2 and 3/4. I'm going to make the 1/2 into 2/4. That's the same thing. So I'm going to add it. So So they have a common denominator. So on top up there, I get 5/4 when I add those, divided by 5/7 when I add the ones in the bottom. And then this division problem, just again, keep the first one, switch it to multiplication, and flip the second one. So those 5's cancel, so we're just left with 7/4.
Now, would you accept 35/20 or no?
No, because that can be simplified. I mean,
if I simplify it then.
so 35/20, yeah, you divide them both by 5, and then it's 7/4.
Alright, sounds good.
Yeah. So then in 15, again, a bunch of simplifying we can do first of all. So 60 and 15 can both be divided by 15. This becomes a 1 and a 4. Then the 14 and 7 can both be divided by 7. So this becomes a 2 and a 1. I'm going to actually kind of put things together now just so we kind of see where we're at. So I have 8, and then I have x to the 4th right now, y to the 2nd. On the bottom, I'd have x to the 4th, y. So again, what I did here, just to kind of try to simplify things up a little bit, once I had all the numbers simplified, then I just multiplied the tops. And now it makes it easy to see that I have an x to the 4th on the top and the bottom. There's y squared on the top, y on the bottom, so there's more y's on top, one more. So it's going to be 8y over 1, or just 8y. So the back all went okay? You guys are good with the factoring and the distributive property? All good there? Okay. So what we're going to do today, I don't know that, I kind of wish I maybe would have changed my, like my plan for this, so I apologize if it's a little bit, it's not very organized in terms of like how we're going to teach all this. But we're learning about these trig identities. So this is a set of rules. And so I'm going to give you this salmon sheet because this is one that you're going to want because you want to put this on your note card. And we do a test on this chapter.
What do you want? What does Luke want? What does I want?
What does he want?
Stuff.
What stuffs?
All kinds of stuff.
Here's your stuffs.
Actually, it's not. No. Some people want to tell. Yeah, you're tired. We don't. They are. With it, he doesn't even care. Yes.
Matthew knows about the TSP.
No, he's trying to. Yes.
Yeah.
What'd you place?
Matthew, hurry up.
He's in
We're gonna have 18.
He's the most generous.
What'd you place?
Now I feel overwhelmed. We're not in the middle of the play. It's like we're never
Oh.
gonna play. Exactly.
Yeah, what'd you place?
What?
Did you have like a tournament to see where you placed?
No,
Okay.
we placed last.
Are you serious? Are you serious?
Literally last.
I thought you guys were winning.
No. We won the first. We played well our first team. And after that, just went down.
Okay, so guys,
It's red.
these spread. So
Salmon.
salmon.
Yeah.
Okay,
You've never seen salmon before?
so
Have you?
they actually kind of, it's not really that far off, but whatever.
That's why.
Okay, so this set of rules here, and so like if you guys kind of see like some of these things should look somewhat familiar to you. So like if you guys look at like these first few, I know we've talked about the fact that tangent is sine over cosine. We mentioned that right when we were talking about our coordinates. So tangent is sine over cosine. So then that being said, is cotangent is cosine over sine. So if I flip that, that's the same thing. Guys, put your phones away, please. Then the reciprocal identities, we talked about these as well, that the reciprocal of cotangent is tangent, reciprocal of cosecant is sine, and secant is cosine. these also work the other way, that you can kind of realize that tangent, the reciprocal, or 1 over cotangent would be tangent. So just being aware that we can kind of rearrange these a little bit is going to be important. So just kind of trying to show you that real quick here. So since we see these, so this also, they don't write this out, but hopefully this makes sense, that tangent then would be what? 1 over, maybe this isn't obvious. Yeah, so tangent would be 1 over cotangent. So same thing would go with sine is 1 over cosecant. So just so you know, there's some rules that they'll just show you, and then others are kind of implied. Like that would be assumed that that would be the case as well. Where this comes into play is these Pythagorean identities. These get used a ton. However, they're not always going to look exactly like this. So sometimes they manipulate them and move them around and they change the order. And so that's why I actually put the backside together, or I took this and had you guys look at this. Is that, sorry, based on what you see there, they won't always show up as sine squared plus cosine squared equals 1. It may be written a different way, and we should be able to manipulate these equations so that they kind of match what we're anticipating. So that being said, what you might see in a problem that will, where'd that go? What you might see in a problem is something like this, 1 minus sine squared of x. However, so if you flip the page over, so this might show up in a problem. What we're doing today is we're simplifying these problems or rewriting them in another way. So 1 minus sine squared of x, we're trying to figure out what that would equal based off of these rules up at the top. What that means is that I might need to manipulate one of these to make it look like this so that I know what it equals. So there's an equivalent statement here. It's not always obvious right away. So, and I'll show you guys this one. This is a pretty straightforward one. So if I want to make this match this, I would take, so kind of my work for this, if I have sine squared x plus cosine squared x equals 1, if I move this sine squared over, just like we would with algebra, 1 minus sine squared x is going to equal what? Yep. So in a problem, we might be able to replace this with that. Those are equivalent to one another. So I'd like you guys to take a minute to try to go through some of these and kind of manipulate them and see if you can get them to match or see what you would know what it would equal based off what you see up here. And if this is really bugging you, and I guess I probably should have laid this out to begin with, this is just like a regular algebra problem where it's like I have x squared plus y squared equals 1. X and y aren't like terms, just like sine and cosine aren't like terms. But I can still move things around to make them, like I can rewrite things and move things over to the other side. So see if you guys can figure out these equal. I'll give you guys a little bit of time. The first two are pretty straightforward. After that, it might get a little bit tricky. So I know this one's negative. I think it's these two. You're doing good. And I'll go through these if you're not seeing what we're doing here. It looks like a few of you guys are getting it, but see if you can, so basically you're changing something about this to make it look like this, and then you want to tell me what that would equal. So there should be like, it's the same thing either way. I can rewrite it. And feel free to check with someone nearby you if you want to see how it goes. Why don't you check with these girls? Have you guys all prepared your answers yet? Because it looks like you guys all have them. And then if they don't match, then let's talk about it.
Basically. And then we went Diego's quiet on this one.
Not for the season, I'll yeah. He's gonna go and pop his shoulder like the Giants game and then say he can't play.
Okay.
Well, I don't know if you can say, can you play that? No. Is it so you're gonna play when you come up?
Technically, I did, but it's a wrong name about it.